This problem is about taking the derivative of a composition of functions. What that means is you need to use the chain rule. Let f of x equal the square root of 5 times sine of x squared plus 10. Evaluate f prime of x. To start this problem, we need to identify any place where there's a composition of functions. The first place we notice it is inside of the square root. We have the square root of the whole expression 5 times the sine of x squared plus 10. There is another composition of functions, and that occurs inside of the sine. We have the sine of x squared. What this means is we have a nested composition of functions. So we will need to apply the chain rule multiple times. Whenever computing derivatives of a function that involves a square root, you can use a trick that will make your life easier. Instead of writing the square root, you can always replace that by whatever was inside of the square root raised to the 1/2 power. Therefore, our function f can be rewritten as the quantity 5 times the sine of x squared plus 10 all raised to the 1/2 power. Now we move on to taking the derivative of our function. Because we identified a composition of functions, we need to work from the outside in, one piece at a time. What that means is the exponent 1/2 is the outermost function, and all of this inside is the inner function. The chain rule says if we want to differentiate f, we need to take the derivative of the outside, leave the inside the same, and then multiply by the derivative of the inside. Here we have the derivative of the outside function. This is a power function. It's the power function with the exponent 1/2. To differentiate that, we bring the power down and then subtract 1 from the original power. We still need to multiply by the derivative of the inside. We need to focus on taking the derivative of this term. Now we encounter another composition of functions. So we need to apply the chain rule again. The outside function is the sine function, and the inside function is x squared. Differentiating 5 times the sine function, we get 5 times the cosine function. We need to leave the inside the same and then multiply by the derivative of the inside. The derivative of the inside is the derivative of x squared, that is 2x. Finally, we still have to take the derivative of the constant 10, which is 0. We collected all the terms and made one cancellation between the 1/2 and the 2. After we rearrange the expression for f prime slightly, we arrive at our final answer, which is f prime of x is 5x cosine of x squared times the quantity 5 sine of x squared plus 10 raised to the negative 1/2. Or, if you prefer to write that using the square root, it reads 5x cosine of x squared all divided by the square root of 5 sine of x squared plus 10. Let's do a quick recap. The first thing we had to do was to identify the composition of functions. There were 2 instances of composition of functions. The second thing we did was a simple trick to make differentiating easier. We replaced the square root sign by the power 1/2. Then it was time to start differentiating our expression. We encountered the first application of the chain rule with the power function, which was the quantity raised to the 1/2 power. The second application of the chain rule came with the sine function. We had 5 times the sine function was the outside function, and x squared was the inside function. After doing these differentiations, the rest was just some algebra to clean up our answer.